this idea of what's called quick graphs? But let me move this up there for right now. Here's my idea. I'm assuming we all know what slope-intercept form is, right? What is it? Good. Slope-intercept form is your y equals mx plus b. Where m is your slope, and what's b stand for? The intercept. Yeah, the y-intercept. Very good. Okay. And when you would graph those things, it was nice. You'd always start at your y-intercept and just walk your slope. If it's positive, you go up and right. If it was negative, you went down and right. Very convenient, very simple way to graph. The other form that you dealt with a lot of times in terms of graphs, sometimes they were given to you what was called standard form. Do you vaguely remember what standard form looked like? What was it? You're nodding your head, yes, Fletcher. Fletcher, yeah. You're close. You're very close. Yeah. Your standard form was that ax plus by equals c. And that was what we called standard form of the equation. A lot of times, that had a bunch of rules with it, where it said that both a and b can't equal 0. They had a GCF of 1, things like that. There's a lot of little parts to it. When you had that form, a lot of times, it was one of the first things that we started dealing with what were called, you ever heard of a term called literal equations? A literal equation is when you take any equation, and let's say I want to solve for t. I've got 3 variables there, I want to get t by itself. What do? You divide by r. So what you did is you solved the equation for t. You did the same exact stuff when you had standard form, 6x minus 3y equals 8. You would go through and you would get y by itself. You'd move everything around and you would solve to get y by itself, because then in your minds, you guys were able to just use slope-intercept form and graph via that way. It's a little more tedious, but that's kind of what you got ingrained into doing. Right? Excuse me. For example, this one here, that's in standard form. Are we okay with that? You guys have been taught to get y by itself. What would you do first to get y by itself? Oh, I don't want to divide by 2x. It's 2x plus 3y. Subtract the 2x. Okay. Everybody see that? So in your minds, you've been taught. Let me just move this page real quick. You guys have been taught to do 3y equals negative 2x plus 12. And then what would you do? You divide the whole thing by 3. And now you have a slope-intercept problem of negative 2/3 x plus 4. You would start your graph at 4, and you would walk your slope down to over 3, down to over 3, and go on your happy way. That's what you guys have been taught to do. Well, when you have this idea of what's called standard form, you can do what's called a quick graph. Quick graphs. Quick graphs are derived from the idea of intercepts. And I don't normally use graph paper. I rarely will use graph paper. And you guys don't need graph paper. I don't want you to try and draw a graph or anything right now. But I want you guys to see where I'm getting at. So just by looking at a graph, when any graph crosses the y-axis, I'm just going to draw a quick little boring line here, as close as I can get. There, it's close-ish. Whenever a line crosses the y-axis, what's the value for x? 0. Okay. Therefore, when it crosses the x-axis, What's the value for y? 0. So you know that the y-intercept, your y-intercept is always going to have an x-coordinate of 0, comma, something. Also, your x-intercept would be at something, comma, 0. Everybody okay with that? This is where the idea of a quick graph comes into play tremendously. Because if I substitute in 0 for y, it goes away, doesn't it? What's your x-intercept then? 6. If I substitute in 0 for x, what's your y-intercept? 4. How many points do you need to make a line? 2. That's the idea. So what we do is this idea of a quick graph, because we don't need to be fancy. We know that if I cover up x, my y-intercept is at 4. If I cover up y, my x-intercept is at 6. Done. Quick graphs. You guys ever seen that before? And some people, I know sometimes you'll see it, sometimes you don't. It's one of those, did you get shown the shortcut? It's a great shortcut. Ideally, I like quick graphs a lot. We're going to use them a lot when we get into solving systems of inequalities. You guys remember solving systems of equations where you graph things, find the intersection point, and go on from there? You can do that with quick graphs. It's a little bit more difficult with quick graphs for equations, but for inequalities, it's awesome because you're just looking for shaded region. Not terrible. Could you figure out what the slope is really quick out of this? Because you've got 2 points, don't you? Don't you just have to walk it? We went down, what, down 4, right 3, so that's down 4, right 3, so that's what, -2 thirds? Yeah, slope is -2 thirds. What's the relationship to the A and B? Your slope will always be the opposite of A over B when you're in standard form. What's that? So I went down to 4 over 6, that'd be -2 thirds. Yeah, you're thinking perpendicular. I was looking at just this slope here. I was talking about when you're in standard form. One of the nice little things that'll happen is that your slope is always the opposite of A over B. That's what I was thinking. Yeah. Let's see. What is the equation of every single horizontal line? All right, start over. What's the slope of every horizontal line? Slope of 0. So horizontal lines has a slope of 0 because there's an O in it. Vertical lines, what's the slope of the vertical line? It is like undefined because it is undefined. Remember, it's the opposite reciprocal of horizontal. You look at the paper on your notebook. You've got all those blue lines going left and right. You've got that red line on the tab side. That is the vertical. Those guys are all perpendicular to one another. They have opposite reciprocal slopes. So the slope here is always undefined. Now, when you think about it, horizontal line goes left and right. When you're on a graph, what doesn't change if you're going left and right? y value. Correct. The y value never changes. So the equation of every single horizontal line is always the same. Y equals some number. What that number is, I don't know. Just whatever number that line's going through. Okay. Whereas your vertical line, what number never changes? The x. So every single vertical line always has the equation of x equals some number. Now, getting into a little bit more of that then, what kind of lines are always parallel to horizontal lines? Horizontal lines. What kind of lines are always parallel to vertical lines? Vertical lines. What kind of lines are perpendicular to horizontal lines? And what kind of lines are perpendicular to vertical lines? Horizontal lines. So when you start thinking about the lingo of all this, let's see, y equals a number is parallel to y equals a number. X equals a number is parallel to x equals a number. But then y equals is perpendicular to x equals. It seems weird to write it like that, but when you start looking at ordered pairs, a lot of times you'll be able to decipher real quick if you've got a horizontal line or a vertical line. If the y values don't change, it's horizontal. If the x values don't change, it's vertical. So you can go real quick and write out some equations. Is this? I know you've seen this part before. Is this someone remember ringing a bell at all? Oh yeah, this one's fun. It's always fun. Let's see. We've talked about two ways to write an equation of a line. What were the first two ways? Sir? You got slope intercept and you've got standard form. What's the other one? It's the one that's actually really, really useful. Yes, sir. Very good. Do you remember what it looked like? There's a y sub 1 in there, yeah. Well, hey, it's part of it. If there's a y sub 1 in there, there's probably a what? Yeah, there's probably an x sub 1 in there. It's a point slope, which means there's probably a, well, there's probably a slope in there, because I'm thinking that's my point right now, the x sub 1, y sub 1. Actually, there's a slope in there. Yes, ma'am. You're close. You're very close to that. When you're talking about point slope form, that just means you have one point and one slope. What you're talking about is you've got 2 points, and then you can determine the slope, which means then you can go ahead and write it down all out. So you guys are close. You just need that. Point slope form is the one that's most useful to start with anything. Because whether or not you are given, not always will you be given a slope and an intercept. You are, great, go to slope intercept form. But a lot of times you're just going to have an ordered pair, or two ordered pairs. If you have two ordered pairs, you can then determine the slope, which means then you can find the slope and then use one of the ordered pairs as the point and then rewrite it into slope intercept form. Now, when I write in equations and stuff, I'm usually going to say, hey, make sure your answer is in slope intercept The reason why I say that is because if you're going to be doing some comparison or you're going to find the intersection between lines or something along those, eventually you've got a button on your calculator that says y equals. Okay. Whereas the standard form is going to be a lot more useful when we use inequalities. When we start talking about what's called linear programming, we're going to talk about feasibility regions. Yes, it's got all the weird. You don't know what that looks like? It's pretty awesome. It's one of my favorite things. It's like word problems. You're gonna love it. Seb would always yell at me for making you guys do it. Why are you doing it? Someday they're gonna have to figure out what's the biggest bang for their buck. Don't be afraid. What? Come on, I gotta scare you every once in a while. It's good for you. Keeps you on your toes. All right. So, we did all this stuff. Yeah, blah blah blah. All right, let's try a couple examples then. See what you remember. We'll come back to this perpendicular one later. So there's two of them here. Write an equation of a line that has a slope of -3 and goes through the point 5 and 2. Then write the equation of a line that passes through the points 4, 8, and 1, 2. Put those both into slope-intercept form. Take a couple minutes, see if you can get it done. Shouldn't be a problem. We'll talk about parallels and perpendiculars. Obviously, you got a slope and a point, so you're going to start with point-slope form. If it's something that you had forgotten how to use point-slope form, if you forgot the formula, just today when you're doing a couple of these problems, just write it out a couple times. Believe me, the more that you write out a formula, the more it'll embed in your brain and you'll remember it. And just fill in the blanks. Y minus 2, -3, x minus 5. Distribute out, you get -3x plus 15. Add 2, you get 17. And then you're done. You okay with that? It's okay. It's okay. This is practice, and that's fine. It's okay to make mistakes, and that's fine. And it's the idea that you catch it, you're like, oh, I'll make that mistake again. It's fine. The other one, you have to find your slope first. That's 17. Sorry, when I erased the 5 part of it, bless you. On the other one, get your slope. You got 2 minus 8, 1 minus 4. Is that -6 over -3? Slope of 2. Now, does it matter which of the ordered pairs you use? No, not at all. Either one, if you math it right, you'll get the right answer. Okay. It does not matter. So we'll just use the first one here. So y minus 8, 2, x minus 4. 2x minus 8, add 8, we get 2x. What is it? Minus 8 plus 8 would be 0. And also, you can always check it real quick because what's 2 times 1? 2. What's 4 times 2? So 2, 4, 6, 8. Who do you appreciate? You think highly of yourselves. It's all right. Do you remember, and I'm hoping you kind of remember this, the process by which you would write out the equations of lines that are parallel or perpendicular? When we deal with writing equations of lines that are parallel or perpendicular, traditionally what I like to do is I like to kind of do a little bit more work than you really need to, because if you follow, I mean, you guys know this. A lot of times in math, it's procedural. Agree with me on that? If you know the procedure and you can replicate the procedure, don't you therefore be master of the procedure? And that's what a lot of you guys are accustomed to doing. there's a time and a place for procedural knowledge as far as how math goes. And then there'll be a time and a place that you have to kind of get out of your comfort zone to figure out how do you get to something. Can you make something work? And that's kind of where I know that most of you guys eventually will start to go, oh, if I can do that. Yes, you can. You just have to trust that not always is it spoon-fed procedural knowledge. It's you take something and go an extra step. So this is procedural knowledge. So what I've always done when I have a parallel or a perpendicular problem is I go through a three-step process. And it sounds like, I don't have to do 3 steps, it's pretty bad. By doing it this way, it takes out a lot of the thinking because you identify what you have to do, you write down what you're gonna do, and then you do it. Right? And that's the idea here, because it's so quick to go too fast and make a dumb mistake. So what I always do is this. Step number 1. Why I say I'm French when I do it, I don't know, but it's kind of funny. What's your original slope? What's the original slope of the line that they want you to be perpendicular to? 3. So the original slope here is 3. Step number 2. Is it a parallel slope or is it a perpendicular slope you're trying to find? Okay, what's perpendicular to 3? Negative 1/3. Okay. Use point slope from that. What's the point you have to go through? What's the slope you're going to use? Point that I'm using, slope that I'm using. See what I'm saying by doing it this way? It makes you remember, are you doing a parallel? Are you doing a perpendicular? And by writing down what you're looking for, it forces you to stop thinking for 2 seconds to remember which part of the problem you're trying to do. It's so quick and easy to overread an instruction and do to do everything that you like parallel because you didn't stop and go, oh crap, it was supposed to be perpendicular. You know, it's one of those things. It just makes you stop and think. So here I just write y plus 6, negative 1/3, x minus 1. Is it okay that I wrote y plus 6 right out of the bat instead of writing minus and negative? I'm going to do that a lot. Whenever we have negatives that get substituted with the y minuses or the x minuses, I'm always going to switch it because it's easy. And now I just solve for y. So let's see, we have negative 1/3 x plus 1/3. Now, when I move that 6 over, I'm going to get a fraction, aren't I? Well, you can do this one of 2 ways. Remember how to create the fraction bar on your calculator? There's a shortcut. On your calculator, there's a shortcut for making a fraction bar. Or sometimes the problems themselves are pretty easy. You can kind of figure it out in your head, which is great if you do. Not, no big deal. We were at Pearl Jam on Saturday night. So they were playing at Wrigley. Eddie Vedder, lead singer, he's a huge Cubs fan. And David Bowie, his walkout music is David Bowie's Rebel Rebel. Probably right. You probably have heard that song before. But when they came out for one of their second set of songs, Vedder started talking about, the Cubs and what it's like now that they won the World Series and everything. And then they wound up inviting Tom Ricketts came out on stage and they brought the trophy. So it's really cool. The trophy's out on stage and they're sitting with it. And then they played, the lights went dim, and then they showed the clip of Bodie when he hit the walk-off grand slam the week before. The place went nuts, and then they played Rebel Rebel right there. So it was just really cool. Yeah, I'm a nerd. Anyway, let me back out of this. So one of the ways to get you, if you guys don't remember, to create a fraction bar on this calculator, alpha y equals. So I'm going to do alpha y equals, and that makes the fraction bar right away. And like I said, the more you play around with this calculator, the better you'll get with it. There may or may not be 1 or 2 tutorials on this thing called the Google when you hit YouTube, I heard. It might be helpful. I already forgot the numbers. What was it, negative 1/3, 1/3 subtract 6. All right. So if I do 1/3 subtract 6, it'll give it to you right away. Or if you recognize 6 in terms of 3 is 18/3, it's not that bad just to move that over. But notice I'm not using a decimal. Decimals are stupid. And that would be your answer. Not terrible. Just remember when you're writing parallels and perpendiculars, just to slow down, go through the steps, it becomes a lot clearer. That's kind of the idea. Yeah, that's all I got. On the calendar, I just put, remember how yesterday we had it where it was like 3 different sections? On the calendar, I just took the 2 sections we didn't get to and just pushed it to today, and I just pushed everything out a day then, which is fine. The PDF files are live on there, and the numbers are on there. Just add them what you've got. If you want to keep like a running tally on the homework sheets, that's great. You start saving them, whatever. Eventually, we'll look at them. Something. Yes, 3 and 4 are on there. Is it 3 or 4? I don't think it's. Yeah, 3 and 4 because then tomorrow we'll do 2-6. I think 2-6 is new for you guys. I don't think you've ever done that one. I think 2-6 is new. Did you guys ever do? Oh yeah, we'll do inequalities. You guys ever graph inequalities? It's 2 variable. You may or may not. It's pretty easy, but what's going to come in handy real fast here? Quick graphs. Everything's done in standard form usually, so they come really fast. Sir. Yeah, it's on the calendar. Yep. Homework's on the calendar.